So today we're going to start chapter 4. We're going to start with section 3. We are going to go back and cover section 1, but we're going to start with the parabolas first. So this chapter is on conics. And what's nice about this textbook is they cover conics early. So for those of you who are juniors, who are going to be planning on maybe taking the SAT in the spring, this chapter will help you because they like to put a lot of SAT questions about conics on the SAT. They end up giving you circles. They give you word problems about parabolas. A classic example that you might see on an SAT dealing with conics is about kicking a soccer ball in the air. They'll say, you kick the soccer ball in the air, and then they'll say, what was the highest point that the soccer ball reached? And that's going to be the vertex of your parabola. Or if they say, how long did the soccer ball spend in the air? And that's going to be the x of your vertex. The y is the height. The x would be the time. If it wants to know how long it took to get to that height, it's the x. If they want to know how long it took before it hit the ground, that would be taking the x value and timesing it by 2. So a lot of conics questions when you go to take the SAT. When we used to use a different textbook, it was actually not until chapter 10. So this is nice that it's showing up in chapter 4, because again, it'll help a lot of you maybe who are going to be planning on taking the SAT soon. So let's go ahead, and these are the different conics we're going to talk about in this chapter. We're going to talk about circles, ellipses, parabolas, and hyperbolas. Now, we've already seen the parabola. The parabolas that we are familiar with are when our graph was either the U or the upside down U shape. But what we're also going to see is parabolas that look like the letter C or a backwards letter C. And that's all going to depend on the variable that's squared. So normally, when we saw something and it looked like this, y equals x squared, remember our parent graph, our graph looked like this. But if the x squared was negative, then we knew it was a sad parabola and it was flipped. Now what we're going to see is we're going to have a y squared, and then that's what's going to produce the graph of the C. So what we're going to see instead of y equals, our equations are going to look like the square term will be first, and then you would be left with a 4py. This 4py is going to help us. We're going to be learning about new different points and a different line that's going to be included in our graph of the parabolas. So when it's x squared equals 4py, then it looks like this. If it's x squared, and if our p-value is negative, then it's going to be the upside down u. For the C, it's going to look like this. It's going to be a y squared equals 4px. And that would be this graph. When it's a negative p-value, then it's going to be the backwards C. And we're going to see all of this and how to identify all of this. So let's go ahead and again define what a parabola is. And a parabola is the set of all points, x, y, order pair, in a plane that are going to be equidistant from a fixed line. And here's the new part. This fixed line is called the directrix, and a fixed point, which is called the focus. Okay, so the focus is a point. The directrix is going to be a line. The midpoint between the focus and the directrix is going to be the vertex. And then the line passing through the focus and the vertex is called the axis of the parabola. Now, we're more familiar with what they're calling axis of the parabola. We were calling this the axis of symmetry. So whenever you're doing a WebAssign or any of the homework, if they say axis of the parabola, they're also asking you to find the axis of symmetry. So be aware of both terms, because on a SAT, they might interchange the two terms. So these are the same, they mean the same thing. Now, this p-value that I showed you in the equation before, the p-value is going to be the distance between the focus and the vertex and the directrix and the vertex. So the p-value is the distance, and it's the distance from the vertex to the focus, and it's also going to be the distance from the vertex to the directrix. This distance between each is the same because it's the same p-value. And again, just like before when we talked about the axis of symmetry, the directrix is also an equation. Okay, so standard form of a parabola, when the vertex is at the origin at 0, 0, the two equations in standard form are the x squared equals 4py and y squared equals 4px. So again, remember when it's the x squared, if the p-value is positive, it'll look like this. If the p-value is negative, it looks like this. For the y squared, it's the c when p-value is positive, and the backwards c when the p-value is negative. P cannot equal 0. Now, a little hint or something that maybe you can memorize, whenever we are trying to find, and in the homework tonight, you're going to ask to find the focus and the directrix. So the equation for the directrix, when it's x squared, is going to be y equals the opposite of p. And when it's the y squared, it's going to be x equals the opposite of p. And then for the focus point, this is going to be, the order pair will be 0, p. But when it's y squared, it's going to be p, 0. So either memorize this or maybe visualize what the graph is going to look like. So remember, the focus lies on the axis, on that axis of symmetry, p units from the vertex. Because again, p is going to be the distance between the vertex and the focus and the vertex and the directrix. So let's go ahead and let's try some of these. Let me add a slide to this just to elaborate and maybe to make things a little bit easier to understand before we start doing examples. I'm going to repeat what I just said. So remember, before we were used to seeing equations as y equals x squared. Now instead, it's going to be x squared equals 4py. Now, these are the standard forms, and the other one is the y squared equals 4px. This is when your vertex is located at the origin at 0, 0. And the way that we can tell that the vertex is at 0, 0 is there's nothing being added or subtracted to my x and y. Coming up in the end of the notes, when we have our vertex that's not at 0, 0, we're going to be introducing h and k again, just like we did when we completed the square. Now, again, just to recap, when your p-value, this thing right here, when p-value is positive, so when it's a positive number, we know our graph is the happy parabola, and this is with the x squared. When p is a negative number, it's going to look like this. And then what we're going to do first is we need to find the p-value. And then remember, for the focus point, when it's the x squared, after we find p, it's 0, comma p. For the directrix, it's going to be y equals the opposite of p. And the way that I can tell the equation, if you want a little hint, this equation here is going to be the non-squared variable from the original. So you see how y wasn't squared? That would be a clue of what your directrix is. Also notice the p in the focus is in that y spot. So notice this is the y spot, and then it's y equals for the directrix. And then over here, when it's the y squared, when p is a positive number, it's the c. When p is a negative number, it's the backwards c. And again, your focus, the non-squared variable is x, so that's where the p goes. And for the directrix, it's going to be the non-squared variable, which is x, equals the opposite of p. So just a little, I guess, summary of what we're dealing with here. And this is when the vertex is at 0, 0. Nothing is being added or subtracted to your squared term or your non-squared x or y. So let's try some examples now. Now, when you're doing the homework tonight, the first, I think, 9 questions are going to ask you to pick the graph. What I would do is use this knowledge that you have. If it's an x squared and then it's a negative p-value, you know you're looking for a graph that's the upside down u. If it's x squared and the p-value is positive, it's the happy parabola. So just use this to eliminate the bad answer choices in the multiple choice. So let's try some examples. Now, my first step is always to isolate the squared term, and it's already isolated. So again, it's already in my standard form. Remember, standard form is x squared equals 4py. I need to find the p-value. My p-value, this number that's right here in front of the non-squared variable, that is equal to 4p. So to find the value of p, I'm going to set 4p equal to the 8. I'm going to divide by 4, and the p-value is 2. Remember, this is the distance from the vertex to the focus, and the distance from the vertex to the directrix. Now, if you memorize, when it's the x squared, remember for the focus point, remember it's 0, comma p. So my focus point is at 0, comma 2, and my directrix is an equation, and it's the non-squared variable. So in my equation, it was the y, and it's the opposite of p. And now I'm going to graph it. Just going to do a rough little graph here. So my vertex is at 0, 0. So that's the red. The red is 0, 0 is the vertex. I'll do the focus in blue. It's at 0, comma 2. And then the directrix is an equation. And it's at -2. Now let me do this in purple. So this is your directrix. So again, I don't care when it's the vertex is at 0, 0. I'm not really concerned about how fat or skinny you make your U. Just remember that the parabola will always surround the focus point, and the directrix will be on the outside of it or behind the U shape. So this is my directrix, and it's an equation. And again, you're just picking a multiple choice graph. I believe the last question you actually have to graph, but the first 9, you're just picking the multiple choice graph. Let's try the next one. Again, this time it's got the y squared. So this tells me it's going to be a C or a backward C. Notice the number in front of x is the non-squared variable x is negative. So this tells me my graph is going to be a backward C. So this is how I could eliminate the bad choices. So again, it's in the correct form. It's the y squared equals 4px. I'm taking this number, the -28, and setting it equal to 4p. Divide by 4, and my p-value is -7. Notice I've got a negative p-value, and it's a y squared, so this tells me my graph will be the backward C. So now let me go ahead and find my focus point. So my focus point, remember, is p comma 0. This time it's the other way. So it's the non-squared variable. So it's -7 comma 0. My directrix, again, look at the non-squared variable. It's x, and it's the opposite of p. So it's 7. So the format is x equals opposite of p. So let's graph this. So again, vertex is at 0, 0. Nothing was added or subtracted to the y squared or the x. My focus point is at -7 comma 0. I'll just say it's right around here. And then my directrix, again, equally distant from that vertex. My directrix is going to be over here at +7. Oops, sorry, it's x equals. So my focus is -7 comma 0. And again, the parabola surrounds the focus, and the directrix is behind it. Again, I'm not asking you to find additional points when the vertex is at 0, 0. But when my vertex is not at 0, 0, then I'm going to be finding an X-intercept or a Y-intercept. Let's try another one. Now, we always need to isolate the squared term. So if there's a coefficient in front, we're going to need to move it first. This one. So again, step 1, isolate the square term. So I need to divide both sides by 4 to get x squared all by itself. And I'm going to turn this into a 1/4 y, because now it's in the correct form. X squared equals 4py. So this time, to find my p-value, I'm going to set 4p equal to 1/4. So 4p equals 1/4. What I'm doing here is dividing both sides by 4 to solve this. So if I divide by 4, divide by 4, what I'm really doing here is 1/4 divided by 4/1, keep flip, change it, and this becomes 1/16. So my p-value is 1 over 16. My focus, when it's the x squared, remember it's 0 comma p, so 0 comma 1 over 16. My directrix is the opposite of p, and it's the non-squared variable, so it's y equals opposite, so negative 1/16. So this would be y equals opposite of p. So let's go ahead and graph this. Now, again, it's 1/16, so again, just make sure that it's equally distant. So here's my vertex. So remember, nothing added or subtracted. So it's a 0, 0. I'm going to put my focus here. I'll say that this is the order pair 0, 1 over 16. And then I can put my directrix equally distant. And this is y equals negative 1 over 16. And again, just draw your parabola surrounding the focus, and then the directrix is behind it. Let's try another one. Again, isolate the square term first. So divide both sides by 8. Y squared equals, again, I'm going to make it 1/8 x, because again, this 1/8 is what 4p equals. Because remember, it's in this form, y squared equals 4px. So I'm going to set 4p equal to 1/8. Now, if the way that I did this over here, dividing by 4, confused you, if it's better for you to think, oh, I'm just going to multiply both sides by the reciprocal, you can also do that. Because that's essentially what I did, because then that simplifies to a 1p, and then I get 1 over 32. However you want to do it, you're isolating p. So now, my focus, remember the focus is going to be p comma 0 when it's the y squared, because remember the p-value goes in the non-squared variable spot. So 1 over 32 comma 0, that's your focus. And then the directrix is going to be the non-squared variable, which was x, equaling the opposite of p. And again, we can go ahead and graph it. Vertex is still at 0, 0. This is the y squared. And notice this time my number in front of the non-squared variable was positive, so it's a c. So again, kind of hard to graph 1 over 32. So I'll just say that this is the order pair 1 over 32 comma 0. And then I'll put my directrix equally distant from that red dot. And this is the equation x equals negative 1 over 32. And again, your parabola will surround the focus. And again, I'm not expecting you to find an additional point. If you do, you could plug in any number you want in there to get an additional point if you wanted to see exactly how wide or skinny it should be. Now we're going to have our vertex not at 0, 0. It's going to be located at another order pair, and that order pair will be HK. Okay, so when the parabola does not have its vertex at the origin, when it's at an order pair, and again, just like before, it'll be H and K. This time, you're going to subtract the H from X and subtract the K from Y. Notice in the basic formula here, there's subtraction signs. So when you go to pull the H and K out, it's going to be opposite of what's there. So always both opposite. Now, technically, you could use this for the 0, 0. Because, for example, let's say the vertex is at 0, 0. My h and k are 0, 0. So if you did x minus 0 squared equals 4p y minus 0, well, when I do x minus 0, this just turns into x squared, and then this just turns into 4p. So if you don't want to memorize this, if you'd rather memorize just both of these, you can. And even when your vertex is at 0, 0, you would just put in 0 and 0 for h and k. And again, same thing as before, the p-value again tells me the distance that the focus is from the vertex, and it also tells me the distance that the vertex is from the directrix. So let's try some examples. Now, when you're doing the homework tonight on WebAssign, always remember to isolate the square term first. So, for example, if number 5 was given to you, let's say number 5 was given to you as x minus 3 squared minus 4y plus 2 equals 0. We need to isolate this thing first. So what I would have needed to do was add this to the other side. Which then makes it look like what was given to me. So in WebAssign tonight, you're going to have to isolate the square term and make it look like this. So what we want it to look like is either x minus h squared equals 4p y minus k. So my square term is isolated. I'm going to go ahead and pull my vertex out. So I'm going to pull out the h and the k. Let me do this in red. So my vertex, opposite of what you think, it's 3, negative 2. Now, I'm still finding my p-value the same way, because the 4 that's right here is equal to 4p. So 4p equals 4, divide by 4, and p equals 1. And again, remember, this p-value is the distance from the focus to the vertex and the distance from the vertex to the directrix. So now, what we need to do, now if it asks you to list the axis of the parabola or the axis of symmetry, remember it's always the x of the vertex. So the axis is x equals 3. That's your axis of symmetry or axis of the parabola. Now, what we need to do is find the focus point and the directrix. So for my focus, this time it's just not 0, p or p, 0, because now it's not 0, 0. So now what I need to do here, when it's an x squared, my focus is going to be whatever h is, and then the k plus the p-value. So for my focus here, my h was 3, my k is negative 2, and my p-value was 1. So my focus point is at 3, negative 1. You have to add the p to the vertex. For the directrix, again, we're going to look at that non-squared variable. So for my directrix, what we're going to do here is my non-squared variable was y. And then again, I'm going to take the y of the vertex and add opposite of p. So p was positive 1. So really what I'm going to do is subtract 1. So my directrix is at y equals -3. Now, when your vertex is not at the origin, if it's an x squared, we're going to find the y-intercept. And remember, to find a y-intercept, I set x equal to 0. So next I'm going to find the y-intercept by setting x equal to 0. So I'm going to take my original equation, 0 minus 3 squared equals 4 times y plus 2. I need to subtract, distribute, square, move the 8, divide by 4, 1/4 equals y. So my y-intercept is going to be the ordered pair 0, 1/4. So now let me graph this. So I'm going to go ahead and graph my vertex. Remember, my vertex was at +3, -2. 1, 2, 3. So my vertex is right here. My focus point is the order pair +3, -1. So focus is in blue, vertex is in red, and now my directrix is the equation y equals -3. And my y-intercept, remember, was the 1/4 here. So my y-intercept is right here. So I need to know how wide to make this. And I can also use my axis of symmetry. Remember, my axis was here. So if I put in my axis of symmetry here, you see how this point right here was 3 spaces away, 1, 2, 3. So 1, 2, 3. I could put another point over here to get the other side of the parabola. And there is your graph. So the parabola will surround the focus, which is the blue point, and then the directrix is always the line behind it. Let's try the next one. Again, isolate the squared term. So I need to divide both sides by 4, -4. So x plus 3 squared. And again, I'm going to put this as a -1/4 because that's what I'm going to set 4p equal to. Now I can go ahead and pull my vertex out. My vertex this time is located at -3, +2. To find my p-value, I'm going to set 4p equal to -1/4. I'm dividing both sides by 4, which is really multiplied by the reciprocal. So my p-value is -1/16. So this tells me it's going to be a sad parabola because it's a negative p-value, so it'll be pointing downward. Now, to find your focus point, remember it's going to be h and then k plus p. So my h value was -3. My k value is +2 plus -1/16. So then this is now going to give me -3. And if I do this, I can make this 1 and 16/16 minus 1/16. So then this will give me 1 and 15/16 for my focus point, because I'm graphing this. And then for the directrix, opposite of p, And again, the non-squared variable, which is y, and then my y value was 2. Opposite of p is positive 1/16. So my directrix is 2 1/16. Again, I need to find, because it's a y squared, an x squared, I'm going to find my x-intercept. If it were the c or the backwards c, I would be finding the x-intercept. So I'm also going to calculate my y-intercept by setting x equal to 0. So again, let me plug in -4, 0 plus 3 squared equals y minus 2. So -4, and then 3 squared is 9, -36, add the 2, -34 equals y. So my y-intercept is going to be 0, -34. So let me go ahead and graph. One, two, three. So again, my vertex was at -3, +2. My focus was at -3 and then 1 5/16. So like right there. And then the directrix is going to be right behind it at 2 1/16. So they're supposed to be both the same distance. And then again, my y-intercept is way down here at 0, -34. So when I go to make this, I'll go like this. And this is 3 spaces away, so I could go 1, 2, 3. Use my line of symmetry here. And then put another point, and it's going to go into my work here. But then this would be the other half of the parabola. So the blue is the focus. The purple is the directrix. Let's do an example with a C, and then we're done. So again, make sure your squared term is isolated. So in the homework tonight, it'll probably be given to you something like this, and it'll have -24x minus 3 equals 0. Just know that you need to move this by adding it to the other side. So then it looks like what was given here. So again, let's pull the vertex out. My vertex opposite. Now be careful. This is H. This is K. Remember, the H is with the X and the K is with the Y. And then my 4P value, it's going to be right here. 4P equals 24. Divide by 4. P equals 6. Now, for the focus, when it's the y squared, we're going to take the x, or the h, so it's going to be h plus p, comma k. So h is 3, p is 6, and then you put the k. That's your focus. For the directrix, the non-squared variable, which is x, and your x equaled 3, and then you add the opposite of p, which will be -6. So x equals -3 is the directrix. Now, this time, because it's the C, I'm going to find the x-intercept. So when the variable that's squared is y, we want to find an x-intercept, the non-squared variable. So this we set y equal to 0. 0 minus 2 squared, 24x minus 3. negative 2 squared, distribute 4, add the 72, 76 equals 24x, divide by 24, and x is equal to 3.2, or 3 1/5, either way. So now, an X-intercept is going to be the order pair 3.2, 0. So now let me get all of this on my graph, my vertex, my focus, my directrix, and my additional point. So my vertex is 1, 2, 3, 3, 2. My focus is at 9, 2, 4, 5, 6, 7, 8, 9. So here's my focus. My directrix is at x equals negative 3. 1, 2, 3. Notice again, the distance between here and here, it's 6. That's your p-value. So this is the directrix, x equals negative 3. And then I'll graph my additional point, my x-intercept, which is 3.2. And then use the axis of symmetry here. And you can see that it's 2 spaces away there. So I could go 2 spaces up this way to get how wide this thing's going to be. And it always surrounds the focus. And again, for like 9 of the questions tonight, you're just picking the multiple choice graph. The last one, you're actually going to have to try to graph it on WebAssign. If it gives you a problem, once you get to that last question, you could try to graph it in your work if you're struggling with the graphing portion on that last question. But the rest of the other 9 questions are just multiple choice. So that is it for the introduction to the parabolas. Tomorrow, I'm going to be giving you a focus or a directrix or a vertex, and you'll have to write the equation. Have a great day.